RHS Precalculus presents
Nathan Goes to the Beach.
Nathan was an extremely good-looking child and always enjoyed the outdoors. While at the beach one day, Nathan dropped his math book into the waves. Lucky for Nathan, he had just read about trig graphs and knew exactly how to figure out how to get his book back.
Hi, I am Nathan. I am at the beach.
Nathan, what are you doing at the beach?
I was enjoying tranquil surf when all of a sudden a shark scared me and I dropped my book into the wave.
Oh no, what are you going to do? Miss Keeler's first period math analysis class is your favorite part of the day.
I know, and since Miss Keeler's first period math analysis class is the ultimate math class of all time, I know exactly how to figure out how to get my book back.
Nathan knew the graph of a sine function, the sine wave, would perfectly represent the waves of the ocean.
One cycle of a sine curve is 2 pi. The sine wave starts at the origin of 0, 0 and has a domain of -infinity to infinity and a range of -1 to 1.
The equation for a sine wave is y equals a sine bx minus c plus b, and the graph looks as follows.
The amplitude represents half the distance between the maximum and minimum values of the function and is given by amplitude equals the absolute value of a. The constant factor a is in y equals a sine x. It acts as a scaling factor, a vertical stretch or shrink of the standard sine wave.
If the absolute value of a is greater than 1, the sine wave becomes stretched. If the absolute value of a is less than 1, the wave is shrunk.
This causes the range to go from -1 to 1 to a negative a to positive a.
Because y equals a sine x completes one cycle from 0 to 2 pi, it follows that y equals a sine bx completes one cycle from 0 to 2 pi over b. Therefore, the equation for the period of the wave is given by 2 pi over b.
If b is greater than 0 but less than 1, the period will be greater than 2 pi and the sine wave will stretch horizontally. Similarly, if b is greater than 1, the sine wave will shrink horizontally.
If b is negative, the identities sine negative x equals negative sine x and cosine negative x equals cosine x can be used to rewrite the function.
The constant c in the equation of a sine wave determines horizontal translations.
The graph of y equals a sine bx is shifted by an amount of c divided by b, and this is the phase shift. The left and right endpoints of a one-cycle interval can be determined by solving the equations bx minus c equals 0 and bx minus c equals 2 pi.
Vertical shift is represented simply as the constant d.
With this information, Nathan could figure out when the waves were at their lowest to go retrieve his book.
And I lived happily ever after.